Good day learners, my name is Jacques Botha. I will be responsible for today's lesson, Natural Sciences lesson on our solar system. It's part of planet Earth and beyond. Now just starting with some background information, things that you've also learned in the primary school on the topic. When we start with the solar system, of course we have to look at pictures. And here we've got a slide of the sun. We can clearly see the sun here, which is the major energy source in our solar system, with all 8 planets in a specific sequence. From the planet which is closest to the sun, Mercury, moving upwards up to the furthest planet from the sun. Right, learners? So in terms of energy from the sun, the energy from the sun is produced by a chemical reaction which takes place inside the sun. We know there's an enormous amount of heat energy available there. There's also a lot of pressure. Now there's a fusion reaction that takes place in the sun where hydrogen atoms are converted to helium atoms, and that reaction we call a fusion or a nuclear fusion reaction. And while that reaction is taking place, an enormous amount of heat and light energy is liberated, which is then set free here in the sun, and it moves all through the universe. Here we can see it passes our Earth, and we get lots of energy there, which can be utilized for different life processes. When we look at the sequence of the planets, starting from the closest one, Mercury, you'll see I've put a label there. It's the first planet closest to the sun. Second one, it's Venus. Then our planet Earth is the third planet from the sun. There's Mars. Jupiter is a huge planet. Planet number 6 is Saturn with the rings. Then we've got Uranus and then Neptune. This label tells us that Mercury is the closest planet to the sun. Again, Earth is the third planet from the sun. And then there we see that Neptune is the furthest planet from the sun. Then you'll see this little dot on the right side of the screen. It says Pluto is a dwarf planet. Now, a dwarf planet doesn't meet the definitions or the definition of a normal planet. It is because it is so small that we don't consider it as a planet. Previously, many years ago, Pluto was still considered as a normal planet, and then we talked about our solar system having 9 planets. At the moment we only talk about 8 planets plus 1 or 2 dwarf planets, of which Pluto is one. Then some other definitions that you must know, learners. When we look at the solar system, we can see here the sun is in the center. There's the Earth and the moon. Now the Earth is moving around. When you follow this broken line, the Earth is moving around the sun. We say that the Earth is revolving around the sun. That word revolve is important. And it takes 365 days for the Earth to revolve around the sun. Same thing, the moon is moving around the Earth, or it is revolving around the Earth, and it takes more or less 28 days for the moon to move or to revolve around the Earth. Then this word rotation, it's got a different meaning. Rotation is when one object rotates or spins around its own axis, and the Earth, of course, rotates around its own axis, and that is rotation. Same thing with the sun. The sun also rotates around its own axis. The moon can also rotate around its own axis. So take care to know the difference between revolution that is one object moving around another object, and then also rotation, where an object is spinning or turning on its own axis. Now this, you'll see here in the red, it says an orbit is a regular or a repeating path that an object in space takes around another one. So an object is the name that we use for the path in which one object moves around another object. Revolution is basically the verb, that is the action which is taken when one object is moving around the other, but this pathway that it takes, we talk about an orbit. Right, here's another picture of the solar system with nice labels here. And now we're going to get to the definitions. Some of the definitions that features in your syllabus. It says the solar system is comprised of the sun and all the objects that are in orbit around and that travels through space as part of the system. First thing which is important, it's the sun, which is the center. It is composed of hydrogen and helium. We know hydrogen is converted to helium, and in the process it gives off a lot of energy. Then we've got 8 planets. There's 4 inner planets. Those are the planets closest to the sun, and they are all made of solid matter. And then we've got the 4 larger planets which are furthest from the sun, and they are all gas giants. So they are mainly made up of gas. Then we've got the dwarf planets, which are very small. They are not defined as planets, and I'm quickly thinking about Pluto and also Ceres. Then we've got moons, which are natural objects, meaning they are made of rock and stone and so forth, and they orbit around planets like our moon. Then asteroids are made up of rock, metals and minerals. They range in size from very small dust particles to a few 100 kilometers in diameter. So asteroids can become very big, and they are made of rock, metals and minerals. Now the asteroid belt is a zone between the planet Mars and Jupiter where most of the asteroids orbit, or then another word for orbit is move around the sun. When we take a look at this picture, we can see over here, these little dots are the asteroid belt. And this is the area or the zone in which we find asteroids. So they are grouped here between Mars and Jupiter. This is where we find the asteroid belts. Then meteors. Meteors are the same things as asteroids, but meteors is not found in a formal belt. They occur randomly inside our solar system, and they also orbit around the sun, but they are not confined to the asteroid belt. Then we've got comets. Comets are frozen gases or ice and dust orbiting the sun, and they are called dirty snowballs. Let's look at the picture and find, over here we can see a comet. You can see that little line there. So a comet also orbits around the sun, and it's got a little tail which always points away from the sun. And we talk about a dirty snowball or a comet. Then the Kuiper belt objects. It's a thick belt of comets and dwarf planets orbiting in a path beyond Neptune. So that is very far. It's the furthest away from the sun. We can see here right at the very right hand side of the picture, there is the Kuiper belt. Then just quickly, natural satellites. Natural satellites are objects orbiting another object. For instance, a moon is a natural satellite, also asteroids and comets which orbits around the sun, whereas artificial satellites are man-made objects which are put in space by man, orbiting the sun and other objects like, for instance, planets. Here I quickly think about communication satellites. Like the satellites which are put into space, they orbit the Earth and they are used for communicating, for instance, like with cell towers. Then lastly, learners, what is the significance of the Earth's position in the solar system? We know it's the third planet from the Sun. The Earth is the only planet that is known to support life. That's important. The conditions that support life on Earth includes the following: temperature. The Earth's distance from the Sun provides the ideal temperature range. It's not too hot or not too cold. You can imagine that if Earth was placed closer to the Sun, like for instance Venus, it would have been much too hot on the surface of the Earth for any living thing to survive. So its position, number 3 from the Sun, is ideal in terms of temperature for us to survive. Then Earth have got water, both in liquid, gas and solid phase. It's because of this temperature range, and that's also ideal for living things. Then it provides sunlight for the food chain, and that is of course for photosynthesis. And lastly, Earth has got an abundance of oxygen gas, which stems from early life forms like algae, which produces oxygen, and that's also very important for life on Earth. Learners, this is a little bit background information on the solar system. Next week we will continue with the solar system. Thank you.